Hi everybody. In this video we're going to talk about what to do if we want to solve a system of equations by graphing as opposed to the elimination method or the substitution method, but those equations are not in slope-intercept form to begin with. And the answer is pretty simple. If you want to solve a system of equations by graphing, but the equations are not in slope-intercept form, just solve for y in terms of x. That means just get the y alone on one side of the equation, and on the other side of the equation you have some expression with x in it, and then that is basically your slope-intercept form, and then you can just graph it easily from there. So let's look at some examples. I have these equations both in standard form, which means that I have some coefficient times x, and then plus or minus some other coefficient times y equals to some number. This one over here is not technically in standard form, but I could write it like this. And then this would be standard form. So I'm just mentioning this because even though I have both of these equations in standard form, or this one is sort of in quasi-standard form, not every single equation that you see is going to be in standard form, but I just have these examples for this video. Okay, so let's just go ahead and start by solving this equation for y. So that means we want to get the y alone. So we're going to have to get rid of this 14x term. And anytime that you don't see a symbol in front of a term, you can put in a plus symbol in front of that. So then the inverse of addition is, so that's positive 14x, but we can think of this as addition. So the inverse of addition would be subtraction. So let's subtract 14x from both sides, except I can't subtract 14x from negative 63 because this term does not have an x in it and this one does. So I'm just going to sort of put it on the side over here. And so then over here, these will cancel out and I'm left with negative 7y. Don't forget to copy this minus symbol over here, which is now a negative. And so equals, and then just copy this negative 63 minus 14x. And so I'm almost done. Now I just want to get rid of this negative 7, which is in front of the y. So that means it's negative 7 times y. So that's multiplication. The inverse of multiplication is division. So let's divide both sides here by negative 7. And remember, if we're doing multiplication or division, we're doing division here, then every single term, then we have to do it to every single term. So not just the negative 63, but also this minus 14x over here. So let's see, negative 63 divided by negative 7 would be positive 9. Negative divided by negative is positive. And then this, I can treat this like a negative, so negative 14x divided by negative 7 would be positive 2. So since I get a positive, I'll write plus 2x, okay? And that is my new form of equation A. So that's equation A written in slope-intercept form, where we have y all by itself on one side, and then we have two terms over here, one term with an x in it and one term without an x in it. All right, let's solve this equation for y, and then once we're done, then we'll go graph these equations and figure out what the solution is. So over here, let's get this term which has x in it. Let's get that to the other side. So again, I could put a plus sign in here, and then the inverse would be subtraction. So be careful, it's not always going to be like that. So for example, if this had been a negative over here, then I would have done addition on both sides, would have added x over 16 to both sides, okay? But it wasn't, okay? I didn't have any symbol here, so which means that I can put a plus sign in there, and then the inverse is subtraction. So I will subtract x over 16 from both sides. Again, this term has an x in it, this term does not, so I can't just do a half minus x over 16 like that. So I'm just gonna push this off to the side. And then on the left side, remember it's the equal sign that separates the two sides of the equation. On the left side, these just cancel out, and I'm left with y over 8. If this is just a plus sign here, then you don't have to bother copying it down like we did over here with this minus sign. We copied that down and said negative 7y. All right, so equals, and then over here I just have 1/2 minus x over 16. Okay, and then the next thing that I'm going to do, I still don't have the y by itself. This is y divided by 8. So what I'll do is I will multiply both sides by 8. Remember, if you're multiplying or dividing, you have to do it to every single term. So I'm going to put these terms in parentheses and multiply both of them by 8. So over here, the 8's just cancel, and I have y equals, and then over here, 8 times 1/2. Let's see, 1/2 times 8, we can put the 8 over 1, and then we'll just multiply the numerators and multiply the denominators. It's pretty easy because these are just ones. So we get 8 over 2, 8 divided by 2 is 4. So this times this is going to give me 4. And then I have a positive times, I can treat that like a negative. So positive times negative is negative. I'll put a minus sign here. Okay, and then 8 times x over 16. Let's see. X over 16 times 8, we can put the 8 over 1. So over here we get x times 8 is just 8x. And over here we get 16. And then what I'm going to do is I'm just going to reduce this. So I can divide the numerator and the denominator here by 8. And that would give me 1x in the numerator and 2 in the denominator. So I could put 1x over 2 like that, or really what I'm going to do is write it this way, 1/2 x. Okay, that's the same thing. All right, so good. So we got both of these equations, which were not in slope-intercept form to begin with. We got them into slope-intercept form. We got the y by itself, and then on the other side, we have an x term and then a non-x term. All right, we have just a constant term over here. All right, so now what we're going to do to solve this system of equations, we could use the substitution method, we could use the elimination method, but this video is about graphing. So we're going to graph them. So let me remember what it was. Y equals 9 plus 2x and y equals 4 minus 1/2 x. I hope I can remember that. Let's scroll down a little bit where I have a coordinate plane here. Okay, so my equations were y equals 9 plus 2x, and the other one was, after we got it into slope-intercept form, y equals 4 minus 1/2 x. All right, so let's go ahead and graph these. So the constant term here is 9. So that means that the y-intercept for equation A is going to be at 0, 9. That's over here. And then the coefficient in front of x is 2, which is the same as, just to get it into the form of a rise over a run, that's the same as 2 over 1. 2 is the same as 2 divided by 1, right? Okay, so I already got 1 point, that's the y-intercept. To find another point, I can use the rise over the run. And this symbol over here is a plus sign in front of the rise and the run. So that means I'm going to be moving up for the rise. When we get over here, here we see a minus sign, which means we're going to be going down for the rise. But this one is a plus sign, so we're going to go up 2 spaces, 1, 2, and then to the right 1 space, because our run is 1. Okay, and then let's just get another few points over here. Now as I go backwards, now just to continue this, I can do the opposite of what I did before. Here I went up 2 and then to the right 1. But now if I'm going on the other side, I can go down 2 and to the left 1 to find another point, and then down 2 to the left 1, okay, and so on and so forth. Really, you only need 2 points to make a line. You just make 2 points and then draw a line through them. But I'm just going to do a whole bunch of points over here, because I know that without those points there, my handwriting is not going to be good. And remember, every single one of these points, and even the points in between, if we even the points in between these points, so for example, like over here and over here and over here and over here, every single point on this line is a solution to this equation, but not necessarily to this equation. So let's go ahead and graph this equation now. So the constant term is 4. So that means that the y-intercept is going to be at 0, 4. So let's do that. I know this is hard to see, but here is the origin, and then here is 4 on the y-axis. So that's 0, 4. And then we have a minus sign here, which means that our rise is -1 and our run is 2. So that means that we're going to go down 1 and to the right 2. Okay, and here's another point. Again, down 1 to the right 2 to find another point. Again, down 1 to the right 2, and so forth. Okay, we can find a whole bunch of points just like that. And then if I want to go backwards to the left of the y-axis, so here I'm always going down 1 and to the right 2. But what if I wanted to go this way and continue this line? I would just do the opposite of what I was doing before. So I would go up 1 to the left 2. Okay, so here would be another point like that, and then up 1 to the left 2, and so on and so forth. Up 1 to the left 2. Okay, and then I could continue this line to the left. Okay, I didn't really do such a great job over there. But anyway, now I can see very clearly that this point over here is where the red line and the green line meet. That is the intersection. So this point is on the red line, which means it's a solution to equation A, but it's also on the green line, which means that it's also a solution to equation B. So let's see. So we have the x value of -2 and the y value, I know that's hard to see, of 5, positive 5. So x is negative, so this point is -2, 5. Let's go ahead and plug these values for x and y into our original equations and see if this in fact is a solution to both of them. All right, so let's go back up here. Now I have to remember it was -2, 5. All right, so back over here. Hey, what happened over here? Here, let's keep that there. Remember that if you want to solve the system of equations by graphing, but the equation is not in slope-intercept form, just solve for y in terms of x. Okay, and then graph, and now we'll check to make sure that we got the right answer. So x was -2 and y was 5, right? So let's plug those in and just make sure that this all works. Okay, so if we did this correctly, then all of this should be equal to -63. So let's see, 14 times -2 is -28. Positive times negative is negative. And then I have 7 times 5 is 35. So I have -35 here. Okay, and then I like to say if these symbols are the same, then the rule is we will add and keep the symbol. So I get 63, but I'm going to keep the symbol, so -63. Okay, -28 minus 35 is -63. So that's good. I got -63 on the left, and we had -63 on the right, so that works. Let's see if it is also a solution to this equation, as it should be. So x was -2. So let's plug that in for x over here. So we have -2 over 16 plus y was 5. So let's plug the 5 in here over 8. So if we did this correctly, we should see that this is equal to 1/2. Well, let's see. Now let's do a little bit of a review of fractions. We can't add the numerators until the denominators are the same. All right, so what I can do here is, this is not such a difficult one. I see that 16 is a multiple of 8. 8 goes into 16 twice, right? So if I just multiply this by 2, and then I have to do the same thing to the numerator, I can say that this is like -2/16 plus, let's see, 5 times 2 is 10 over 8 times 2 is 16. All right, so I got the denominators the same. Is this really equal to 1/2? Let's see. Now I can add the numerators. So -2 plus 10 would be -8. Think of a number line. Okay, if I start at -2 and then I add 10, which means I go to the right 10 space, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I would end up at +8, right? So I'm going to get over here 8 over 16 equals 1/2. Is that a true statement? Yes, because I can reduce this. I can divide this and this by 8. Okay, that's a factor of both of them. And then so finally I have here 8 divided by 8 is 1, 16 divided by 8 is 2. So I get 1/2 equals 1/2. Okay, so there it is. I had a system of equations that I wanted to solve by graphing, but they were not in slope-intercept form, which just makes it harder to graph if they're not in slope-intercept form. So the first thing we did was we put them into slope-intercept form. Then we graphed them, and we found where they intersected. And the point where they intersected, since it's on both lines, it's a solution to both equations. And then just to check that, that's what we did right over here. This is where they intersected at -2, 5. So we plugged them back in. We plugged the numbers -2 in for x and 5 in for y. And we saw that, yes, indeed, that was the solution to both equations. Okay, if we plug those numbers in, then both sides are equal for both equations. Okay, so everything works out. And that's it. Have a great day.